In this video, we're going to look at graphing a lemniscate. Consider the equation r squared is equal to the cosine of 2 theta. And to start with, let's graph the right-hand side of this equation in the theta r plane. In the theta r plane, cosine of 2 theta would be a trig function with a period given by 2 pi divided by b. Or in this case, 2 pi divided by 2, which is just pi. So the period to see one cycle of the cosine function is just pi. So on the interval 0 to 2 pi, we'll see 2 cycles of the cosine function. And our graph will look something like this. We don't want to use the entire cosine graph given here, though. Since the left-hand side of our equation is squared, it will always be positive. Thus, we want to restrict ourselves to portions of the graph cosine of 2 theta, where this is also going to be positive. This is going to be on only the portions above the x-axis. So we won't use this portion down here. We'll be using only this portion of the cosine graph. Recall, it's also convenient if we know places where our graph crosses the theta axis. That would be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. These are values of theta where our radius is going to be 0. It'll be values where our graph lives at the origin, or the pole in the coordinate system. These angles, pi over 4, would live in the first quadrant, 3 pi over 4 in the second quadrant, 5 pi over 4, and 7 pi over 4 would look like this. For values of theta between 0 and pi over 4, our radius would be always given by our graph. And for values between 0 and pi over 4, our radiuses are always positive. At 0 radians, we have a maximum radius of 1. And so our graph would start right here at 1 when we're pointing in the 0 radian direction. As theta increases from 0 to pi over 4, the radiuses get smaller and smaller and smaller until eventually being 0 at pi over 4. And so our graph in the polar coordinate system will probably look something like this. Between pi over 4 and 3 pi over 4. Between pi over 4 and 3 pi over 4, the graph does not exist. Our graph does not resume until after we get to 3 pi over 4. And then from 3 pi over 4 to 5 pi over 4, our radiuses are always going to be given by our graph, and they're going to be, again, positive. They'll be the longest positive at pi. And so at pi radians, when we're pointing to the left, our radius will be maximum length. It'll be a length of 1. It'll be about right here. And as we extend from 3 pi over 4, our radius would be 0. It'll get longer and longer and longer until eventually it's a 1 at pi. After pi, the radius will still be positive, but getting shorter and shorter and shorter until eventually 0 at 5 pi over 4. So as we rotate through this third quadrant, our radiuses will get smaller and smaller. Oh, let me draw that again. As we rotate from 5 pi over 4 to 7 pi over 4. Well, from 5 pi over 4 to 7 pi over 4, our graph doesn't exist. Our graph doesn't resume again until 7 pi over 4. And after 7 pi over 4, the radiuses will always be positive again, being a longest at 2 pi. And so as our graph rotates from 7 pi over 4, we'd start with a radius of 0. And as we go from 7 pi over 4 to 2 pi through this area, our radius will get longer and longer, eventually reaching a length of 1 again at 2 pi. Well, this is the graph of a lemniscate. I hope this is helpful, and I'll see you guys next time.